Somewhere out there, right now, one of the most iconic images in all of science is dying. Not slowly fading the way stars do over billions of years. Not quietly eroding the way coastlines do over centuries. It is draining away at a rate that, if you sat down and did the math, would make you put the numbers down and check them again. Every 30 minutes, the equivalent of an Olympic-sized swimming pool of material disappears from Saturn's rings and falls into the planet. Every 30 minutes, every single day. And it has been doing this long enough that scientists now believe the rings have, at most, 100 million years left. That sounds like a long time until you realize the rings themselves are only somewhere between 100 million and 400 million years old. They are not ancient. They are not permanent. They are, in cosmic terms, a temporary accident that we happen to be alive to witness. And buried inside those rings, carving through them from the inside, is a moon so small it does not even appear on most diagrams, 8 kilometers across, smaller than some cities. And it has been making waves that no one asked it to make, in a gap no one told it to cut, for longer than our species has existed. Subscribe if you want to understand what is actually happening out there. Now, let's begin. In 1610, Galileo pointed a telescope at Saturn and saw something that confused him deeply. The planet appeared to have two large companions sitting close on either side of it, like bulges or handles. He described them as ears. He had no framework for what he was actually looking at, and his telescope was not strong enough to resolve the truth. He died without ever knowing what those ears really were. 45 years later, Christian Huygens figured it out. What Galileo saw as ears was actually a flat continuous disk of material wrapped entirely around the planet, tilted at an angle, orbiting silently in space. A ring, and from that point forward, Saturn's rings became the most recognized, most studied, most assumed permanent feature in all of planetary science. For the next 3.5 centuries, that assumption went almost completely unchallenged. The rings looked ancient, they looked structural, they looked like something that had always been there, and always would be. Textbooks printed them as a defining characteristic of Saturn itself, as though the planet and its rings were inseparable. That assumption was wrong. And we did not find out how wrong until 2004, when the Cassini spacecraft arrived at Saturn and began 13 years of the most detailed observation any planetary system has ever received. In the final months of the mission, in 2017, flight controllers sent Cassini on what they called the grand finale. 22 consecutive dives through the narrow gap between Saturn and its innermost rings. No spacecraft had ever gone there. The region was unmapped. And the data Cassini transmitted back, right up until the moment it burned apart in Saturn's atmosphere, rewrote the entire story. The rings are not 4.5 billion years old. They are not a relic from the formation of the solar system. Current estimates, based directly on Cassini's measurements, place their age somewhere between 100 million and 400 million years. To put that in perspective, dinosaurs were walking the Earth when Saturn's rings were still forming. Some models suggest that when early mammals were first evolving, Saturn may have had no rings at all. 400 years of assumption, erased by 13 years of actual data. In all the images Cassini sent back over 13 years, there was one set that made scientists look twice, then look again, then call other people into the room. Inside a dark, razor-sharp gap, cutting through Saturn's A-ring, something was moving. A faint white dot, small enough that researchers had to comb through images frame by frame, just to confirm it was real, and not an artifact of the camera. When they finally locked onto it, they measured it. 8 kilometers from end to end. Not round. Elongated, roughly football-shaped, with a faint ridge running around its equator where ring material had slowly accumulated onto its surface over millions of years. It had the approximate dimensions of a small city. Manhattan is larger. Its name is Daphnis. It was discovered in May of 2005, and no ground-based telescope had ever seen it, or ever could. It exists at a scale that only becomes visible when you send a spacecraft close enough to resolve detail measured in kilometers against a backdrop of billions of ice particles. Daphnis sits inside what is called the Keeler Gap, a dark channel approximately 42 kilometers wide that cuts cleanly through the outer portion of the A-ring. The gap itself was first observed by the Voyager spacecraft during its 1981 flyby of Saturn. Scientists noticed immediately that the edges of the gap were not smooth. They had a faint, rhythmic waviness to them, as though something inside the gap was pulling on the surrounding material. They had no explanation. They simply noted it and moved on. Cassini found the explanation. That waviness, those subtle disturbances running along both edges of the Keeler Gap for tens of thousands of kilometers in every direction, was the signature of one 8-kilometer rock doing something that should not be possible at its size. What exactly it was doing is where this gets difficult to believe. To understand what Daphnis does, you first need to understand what the rings actually are at close range. They are not a solid surface, they are not a smooth disk, they are trillions of individual chunks of water ice, ranging from grains of dust to boulders the size of houses, all orbiting Saturn at enormous speeds, all packed into a layer that in most places is no more than 10 meters thick. Imagine the entire continental United States covered in a sheet of paper. That is the proportion. Vast horizontally, nearly nothing vertically. Now place a moon inside that sheet, a moon with its own gravitational field, however small, and give that moon an orbit that is not perfectly circular, not perfectly aligned with the ring plane, but tilted by a fraction of a degree off horizontal. That fraction is everything. As Daphnis moves through the Keeler Gap, it does not simply push ice particles aside the way a snowplow moves snow. Its gravity reaches outward and upward, tugging on the ring particles lining both edges of the gap. Those particles get pulled inward and lifted slightly above the ring plane. Then Daphnis continues forward, and the gravitational pull weakens. The particles, released, spring back toward their original positions, but they overshoot, they oscillate. They do not simply return and settle. They bounce past their starting point, pull back, bounce again, forming a wave that propagates along the edge of the gap. Then Daphnis comes around again. 14 hours later, another gravitational tug, another wave, layered on top of the last one. The result is a scalloped, rippling edge running along both sides of the Keeler Gap, with individual wave peaks reaching heights of up to 1.5 kilometers above the ring plane. 1.5 kilometers, rising out of a surface 10 meters thick. That ratio is not a typo. On a structure thinner than a modest office building is tall, a moon the size of a city district is raising ice formations higher than most mountains on Earth, purely by existing and moving through the neighborhood on a slightly imperfect path. When Cassini photographed this in high resolution during its closest flyby of Daphnis in 2017, the images looked almost fabricated. A small, bright object trailing two fishtailing walls of ice stretching away to either side, like a speedboat crossing a perfectly still lake. Except the lake was a ring of frozen particles hundreds of thousands of kilometers wide. Those images became some of the most widely shared photographs of the entire Cassini mission. Not because they were enhanced or dramatized, because the reality itself was that strange. Here is where the story becomes more complicated than most accounts let on. The natural assumption, when you hear that a moon is carving through a ring system and generating waves and flinging particles into unstable orbits, is that the moon is straightforwardly destroying the rings. That Daphnis is an agent of erosion, plain and simple. But the scientific picture is considerably messier than that, and it is worth being precise about what we actually know versus what we are inferring. What we know is this. Every time Daphnis completes an orbit, it displaces ring material. Some of those displaced particles end up on trajectories that lead them inward, where Saturn's gravity can eventually pull them all the way down into the planet. Daphnis is adding energy to a system that is already losing mass. That part is not disputed. What is less settled is the question of net effect. A minority of researchers have argued that embedded moons like Daphnis may actually extend the structural coherence of the rings by maintaining clean gap boundaries. Without something actively clearing the Keeler Gap, the argument goes, material would gradually diffuse back in, increasing the density of particle collisions in that region and potentially accelerating large-scale fragmentation in ways that are harder to predict and harder to reverse. Daphnis, on this reading, is not purely a destroyer. It is also, in a complicated way, a stabilizing force. This is not a settled debate. The data supports both interpretations to varying degrees, and the honest answer is that our models of ring dynamics are still being refined. This is not unusual in planetary science. It is in fact the normal condition. Einstein added a cosmological constant to his equations to prevent an outcome he did not believe in, then called it his greatest mistake, and then watched as later generations found evidence suggesting something very much like it might be real after all. Science does not move in straight lines. It moves toward better data. What Cassini gave us was better data than anything that came before it. What that data has not yet given us is a complete picture. Daphnis is not the only actor here. Pan, Atlas, Prometheus, Pandora. At least a dozen small embedded moons and moonlets, each maintaining its own gap, each generating its own smaller disturbances, each contributing to a system that is simultaneously structured and self-consuming. Daphnis is simply the one caught most clearly on camera. Step back from the data for a moment. You are sitting somewhere right now, reading or listening to this, and every atom in your body is subject to the same gravitational mechanics that make Daphnis raise kilometer-high waves in a sheet of ice 700 million miles away. Gravity does not have a range limit. It does not switch off at the edge of the solar system. The same force bending ring particles into oscillating waves is pulling you against the surface of this planet right now, at this exact moment as you process this sentence. That is not a metaphor. That is the physics. But here is what makes this genuinely difficult to sit with. The rings of Saturn, the image that appears on every astronomy textbook cover, every planet diagram, every child's drawing of the solar system, are not a permanent feature of the universe. They are a temporary accident, a window, and we exist inside that window. If the human lineage had emerged 300 million years earlier, Saturn would have been a featureless pale yellow sphere in the night sky. No rings, nothing to point at, nothing to inspire 4 centuries of observation and wonder. If our descendants are still here 200 million years from now, they will look up and see the same thing. A plain, ringed planet on every yellow globe, with no rings worth mentioning. We are the only version of this species that gets to see it. Not because we earned it, not because we looked at the right time, simply because this is when we happen to exist, in the narrow window between formation and disappearance, watching something beautiful drain away particle by particle, while we are just barely smart enough to understand what we are looking at. In 2022, a team of researchers at MIT published a paper in the journal Science proposing an explanation for where Saturn's rings came from. It is important to be clear about what this is, a hypothesis, supported by indirect evidence, not yet confirmed by direct observation. With that framing in place, it is one of the most compelling ideas in recent planetary science. The hypothesis is called Chrysalis. It proposes that Saturn once had an additional large moon, which the researchers named Chrysalis in the paper. Sometime between 100 million and 200 million years ago, according to the model, Chrysalis drifted into an unstable orbital resonance with Saturn's other large moons. Its path became erratic. It was pulled progressively closer to Saturn until it crossed what is known as the Roche limit. The Roche limit is not a theoretical abstraction. It is a calculable boundary, specific to every planet and every moon, inside of which the tidal forces exerted by the planet become stronger than the self-gravity holding the moon together. Cross that line, and the moon does not crack or chip. It comes apart systematically, layer by layer, until nothing coherent remains. Chrysalis crossed that line. Saturn's gravity dismantled it. The debris, no longer bound to a single object, spread and flattened into a disk along Saturn's equatorial plane. That disk, according to this hypothesis, is what we now call the rings. If that is correct, then everything we have been looking at for 4 centuries is not a primordial structure. The shredded remains of a moon that no longer exists, still orbiting the planet that destroyed it, slowly falling back in. And Daphnis, which almost certainly formed from that same debris field, is a fragment of Chrysalis that clumped together, gathered enough gravity to hold its shape, and became an independent object. A piece of the destroyed moon, born from the destruction, now orbiting inside the remains of its own origin. Every wave Daphnis raises in the Keeler Gap is, under this hypothesis, a disturbance in a graveyard, the child of a catastrophe, endlessly stirring the evidence of the event that created it in a ring system that is itself the aftermath of something that no longer exists. In 1610, Galileo pointed a telescope at Saturn and saw something that confused him. The planet appeared to have 2 large companions sitting close on either side, like handles or bulges pressed against its edges. He described them as ears. He had no framework for what he was actually looking at, and he died without ever finding out. 45 years later, Christian Huygens resolved the problem. What Galileo had interpreted as ears was a flat continuous disk of material wrapped entirely around the planet, tilted at an angle, orbiting in silence. From that point forward, Saturn's rings became the most recognized and most assumed permanent feature in all of planetary science. That assumption held for 3.5 centuries. Textbooks treated the rings as a defining characteristic of Saturn itself, ancient and inseparable from the planet. No serious challenge emerged until 2004, when the Cassini spacecraft arrived at Saturn and began what would become 13 years of observation at a level of detail no planetary system had ever received. In 2017, in its final months, Cassini executed the grand finale, 22 consecutive dives through the gap between Saturn and its innermost rings. No spacecraft had ever gone there. The data it transmitted before burning up in Saturn's atmosphere overturned everything. The rings are not 4.5 billion years old. Cassini's measurements place their age between 100 million and 400 million years. Dinosaurs were still walking the Earth when these rings were forming. Some models suggest early mammals were already evolving before the rings existed at all. 3.5 centuries of assumption, dismantled by data. The questions Cassini raised did not come with answers attached. They came with a list of things we do not yet have the instruments to resolve. We do not know with certainty how old the rings are to within an order of magnitude. We do not know whether the Chrysalis hypothesis will hold up against future observation or collapse under better data. We do not know the precise rate at which Daphnis and its companion moons are accelerating the system's decline versus simply participating in a process that would proceed at roughly the same pace without them. What we do know is that better instruments are coming. The James Webb Space Telescope, which has been operational since 2022, has already imaged Saturn in the infrared with a level of clarity that was not possible before. Those observations are still being analyzed, and early results are beginning to place new constraints on ring composition and mass that will feed directly into age estimates. The Dragonfly mission, currently en route to Titan, Saturn's largest moon, is scheduled to arrive in the mid-2030s. Its primary objective is Titan's surface, but its trajectory and instrumentation will add to the broader dataset on the Saturnian system. Further out, the next generation of ground-based observatories will bring additional resolution to bear on questions that Cassini could only partially answer. None of these missions will give us the complete picture immediately. Science does not work that way. Each instrument narrows the uncertainty by a fraction, and the fractions accumulate over decades into something approaching clarity. The rings will still be there when the data arrives. Probably. An 8-kilometer rock is making waves right now. Not metaphorically, physically. At this moment, as you finish this sentence, Daphnis is somewhere inside the Keeler Gap, completing another orbit, dragging its gravitational signature along both edges of a 42-kilometer clearing, raising walls of ice 1.5 kilometers tall out of a surface 10 meters thick. It has been doing this for millions of years. It will continue doing this for roughly 100 million more. And at no point in that entire span does it require an audience. That is the part that stays with you. The waves were there before Cassini photographed them. They were there before Voyager flew past in 1981 and noticed the gap without understanding it. They were there when Galileo misidentified the entire ring system as ears. They were there when the first humans looked up at Saturn and saw nothing but a slightly odd star that did not quite match the others. Gravity does not perform. It does not wait to be observed. It simply operates, at every scale, in every direction, without pause and without preference. A moon the size of a city district reshaping a ring system hundreds of thousands of kilometers wide, not because it is trying to, but because it is there and physics is consistent. What Daphnis leaves behind is not just waves in ice, it is a record. Every ripple along the Keeler Gap is a timestamp, a physical impression of a gravitational event that happened minutes or hours earlier. The universe keeps its own records. We are just now learning how to read them.